Okay, here's a quick example of a PNP switch. So I'll draw my circuit first. So my source voltage is going to be 9 volts. This is going to be ground. This is my RB, and this is 1K. And I'm going to have a resistor on my collector. So this is my emitter, collector, my base. And this is going to be 400. And then this is ground. Okay, so what I'm going to do in this one is I'm going to find VB, VC, VE, VCE, and actually VEC, EC, IB, IC, and IE. Okay, so I'm going to represent this as 2 circuits. So, and I'm going to just do saturation in this case. So we know in cutoff, everything is off. And in saturation, we have 9 volts. Here's my E, my diode to B, my resistor. So this is my RB. And then this is ground. And this is 1K. And then my emitter to collector. This is my E. This is my C. My RC, which is 400. And this is ground. Okay, so the first thing to look at is notice that VE is equal to 9 volts. It's directly connected to the battery in both the emitter to base and emitter to collector scenarios here. So that's good. We also can see that VC is also 9 volts. And we weren't told here that there's any voltage drop between E and C. So we're going to assume it's 0. If it wasn't, it would be 0.3. And so then it would be VC is 9 minus 0.3. But since we didn't say that, we're going to leave it at just 9 volts because there's nothing, we're not representing it with anything. We're not saying there's any voltage drop. We're saying it's negligible. But what about B? Well, so if I look at B, I know E is at 9 volts, and I know I need to drop 0.7 volts. So my VB is going to be equal to VE minus 0.6 volts, or 0.7 volts. We'll leave it at 0.6. And VE is 9 volts, so it's going to be 9 minus 0.6 volts. So VB is equal to 8.4 volts. Okay, so, and we also know that VEC is equal to 0 volts. So we've got all our voltages. Now we can go to our currents. So since we know our base voltage is 8.4, so we have got 8.4 volts to drop across the 1K. So we're going to say IB is equal to VB divided by RB. And so IB is equal to 8.4 divided by 1K. And so IB is equal to 0.0084 amps, or IB is equal to 8.4 milliamps. I got a little voltage in there by mistake. Amps and milliamps. Okay, so we've got our IB. And now what about our IC? So our IC is equal to, looking back, I've got, I don't lose any voltage between E and C, so I'm going to have the full voltage. So I'm going to say VC divided by RC, and so that's going to equal 9 volts divided by 400 ohms. So IC is equal to 22, so 0.0225 amps, and IC is equal to 22.5 milliamps. And so to find IE is IB plus IC, And so that is going to be IE is equal to 8.4 milliamps plus 22.5 milliamps. So IE is going to equal 30, actually. 30.9 milliamps.